Hello everyone. In this video we're going to be solving a logarithmic equation. We have log 72 with base 2n and log 18 with base n. And we're going to be solving for the n values. I'll be presenting two methods, and let's start with the first one. For my first method, I'm going to use a formula called change of base. Change of base, we talked about it in previous videos, but let me kind of show you one more time. If you have log a with base b, you can write it as log a over log b, and you can basically attach any base you want. I'm just going to use x in this case. So, and a lot of times it's helpful or more convenient to use base e, natural log, ln, or base 10, which is just log. So I'm going to use ln for this problem. Let's go ahead and write log 72 base 2n as ln 72 over ln 2n. And let's go ahead and write the second expression as ln 18 over ln n. I want to leave some space between the ln and the n so that they don't get confused or they don't get mixed up. So we have two expressions that are equal. Therefore, this is going to be set equal to this one. Let's go ahead and do that, right? So we have ln 72 over ln 2n equals ln 18 over ln n. So how do you solve for n from here, right? The first step should be cross multiplication. Let's go ahead and cross multiply. From here we get ln 72 times ln n equals ln 2n times ln 18. Now there's a couple things we can do here. First of all, we can split this up. For example, ln 2n can be written as ln 2 plus ln n using the product property. And we can go ahead and substitute that here. And let's go ahead and do it. ln 72 multiplied by ln n equals ln 2 plus ln n, which replaces ln 2n, and that is going to be multiplied by ln 18. Great. Now we can go ahead and distribute the expression on the right hand side. Ln 72 times ln n equals ln 2 times ln 18 plus ln n times ln 18. Now we have ln n on both sides. Let's go ahead and put them together and factor out. So we're going to take out ln n, and ln 72 minus ln 18, that's what we get by subtracting that expression. That equals ln 2 times ln 18. Awesome. Since we're looking for ln n, we're going to go ahead and divide both sides by this difference. But first, we can go ahead and simplify this. This can be written as ln 72 over 18. We're condensing using the quotient property. And that's actually the same thing as ln 4, because 72 divided by 18 equals 4. So our expression simplifies as ln n times ln 4 equals ln 2 times ln 18. So at this point, we can go ahead and isolate ln n. So let's go ahead and divide both sides by ln 4. So ln n becomes ln 2 times ln 18 divided by ln 4. Now notice that ln 4 can be written as ln 2 squared, and the 2 can be moved to the front because that's an exponent. So the bottom left hand side is ln n still. We get ln 2 times ln 18, and at the bottom we get 2 times ln 2. Now the ln 2 cancels out. Let's go ahead and cancel those out. And we end up with something that looks like this. Let's rewrite it, ln 18 over 2. So how do you find n from here? One of the things you can do is write the division by 2 as 1/2 and then go from there. Or you can cross multiply if you want. Let's go ahead and do cross multiplication. If you multiply like this, we get 2 ln n equals ln 18. Obviously, you could directly do that like just by writing it 1/2. From here, you can write ln n equals 1/2 times ln 18. So either way, you're going to get the same answer. So Our goal is to get an ln on both sides, but we don't want any coefficients. So 1/2 needs to go. Let's go ahead and put it up here. So that becomes ln n equals ln 18 to the power 1/2. In this case, we're dealing with positive numbers because ln is only defined on the positive reals. So we can go ahead and set the arguments equal, n equals 18 to the power 1/2, which can be written as square root of 18. And square root of 18 can be simplified as 3 root 2. Obviously, we could also do the following. If we proceed from here, this can be written as ln n squared equals ln 18. I know I kind of made them too close. And then we could write n squared equals 18, which would give us 2 results, but the -1 is not going to count. Therefore, we're only going to go with 3 root 2. Make sense? Hopefully it does. Let's go ahead and take a look at the second method. The second method. For the second method, let me rewrite the problem. We're going to go ahead and use substitution because it's very helpful in most cases. Let's go ahead and set both of these equal to x. And let's see what that implies. So first of all, write this, set it equal to x, and use the definition of logs. And what does the definition say? Start here, that's the base, and that's the exponent, and this is the result. That's what the definition says. So from here we can say 2n to the power x equals 72. And from the second equation, we can do something similar. This is the base, so start here and then go here, n to the power x equals 18. Great. So now we kind of have like a system of equations, but this system is easy to solve because 2n to the power x can be split up. So we can write this as 2 to the x times n to the x, and that is equal to 72. So we kind of used a property of exponents here. Hopefully you're familiar with that because we did this many times. And from the second equation, we do know that n to the power x equals 18, right? So we can go ahead and substitute that. Take a look. We have n to the power x here, and we know that it's equal to 18. So we can go ahead and replace that with 18, and we get a very simple equation. This gives us, upon division by 18, we get 2 to the power x equals 72 divided by 18, which is 4, and this gives us x equals 2. But we're not looking for x, we're looking for n. And from the second equation, we have n to the power x equals 18. Since we know that x is 2, this turns into n squared equals 18. And as before, we get 2 results, but remember what we said about n, because n and 2n are the bases, so they have to be positive, right? And they have to be different from 1. So that's the requirement. Therefore, negative numbers we cannot use. So that is going to be the answer. Now let's go ahead and take a look at the graph, and you're going to see how the graphs kind of work out. And here's the graphs of these two functions, and they intersect at a single point, which is where x equals 3 root 2. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.